If possible, find the exact value of each expression. Here we have the arc sine of -1/2. So in other words, we're looking for an angle whose sine is -1/2. In other words, this is equal to some angle, I'm going to call it theta, where sine of the angle theta is equal to -1/2. And we have this restriction that we know that the range of the inverse sine function is -π/2 to +π/2. So we're looking for an angle where the sine is -1/2. I'm going to go ahead and just draw our unit circle here. This is very sloppy. I'm actually going to redo this because it's going to. So here's our unit circle, and we're looking for when the sine is -1/2. Now the sine is -1/2 in a couple places on the unit circle. We've got right here and right here. And of course those could be multiple different angles depending on how many times you go around the circle and which direction you go. However, the arc sine will only give us something between -π/2 and +π/2. We're only allowed to have things there. So we have this angle here then. It's just going to be that angle right there that we're looking at, which is -π/6. -π/6. So that's the arc sine of -1/2. Okay, the inverse sine of √3/2. Again, this is an angle. And so we're looking for when the sine of some angle is equal to √3/2. So I'm looking for when that happens. And from our knowledge of the unit circle, okay, there's a place up here where the sine is equal to √3/2. And since we can only get things between -π/2 and π/2, we know that that's this angle right here, which is π/3. So the inverse sine of √3/2 is π/3. Okay, finally here, sine inverse of 2. In other words, if this would be some angle where the sine of that angle is equal to 2. However, we know that the sine has a range of -1 to 1. Sine will never give us a number outside that range. It can never give us 2. And so this has no solution. This does not exist. Does not exist. Okay, 2 is outside the domain of the inverse sine function.